Hello guys, how's it going? Sorry that I'm here with this teacher, but the thing is that I went to walk my dog and make some shopping to eat, and there was a huge storm on the way, so I needed to change my clothes right now because I don't want to get sick. Anyway, we're gonna continue with the prompt engineering with OpenAI. It's gonna be the part 2 because in this path I am in the second course, and in the second course there's many models. I am the second model, I think. Anyway, I'm still working on prompt engineering with OpenAI. So let's go right into it. Here we are.
In this video, we will discuss prompting techniques to understand the output a model returns. Chain of thought prompting requires language models to present reasoning steps or thoughts before giving a final answer. This technique is valuable for complex reasoning tasks and helps reduce errors by processing the reasoning step by step. To understand the power of chain of thought prompts, let's compare them with standard prompts using a math problem. Suppose we want to determine how many books a person has given their existing count and their lending and purchasing decisions. A standard prompt gives us a number but doesn't explain the reasoning. We can verify its correctness without seeing the steps taken. To address this, use a chain of thought prompt asking the model for a step-by-step explanation. The model solves the problem as a series of 5 steps, providing the correct answer. We can use few-shot prompts to obtain chain of thought reasoning. Instead of instructing the model to generate reasoning steps, we provide examples of what the answers should include. For instance, to determine if a group of odd numbers adds up to an even number, we provide an example question and answer. This exemplifies the steps: finding the odd numbers first, then summing them to verify the statement. We then provide a new question with an A for the model to answer. We combine the example and the question to obtain the final prompt. As a result, the model follows a similar logic in its response. Let's study the difference between multi-step and chain of thought prompts. With multi-step prompts, the various steps of the task are directly incorporated into the prompt itself, guiding the LLM's behavior. Chain of thought prompts take a different approach by instructing the model to generate intermediate steps or thoughts in its output as it solves the problem. This helps gain insight into the model's decision-making. One limitation of chain of thought prompting is that one thought with flawed reasoning will lead to an unsuccessful outcome. This is where self-consistency prompts come in. Self-consistency prompting is a technique that generates multiple chain of thought responses by prompting the model several times. The final output is determined by a majority vote, selecting the most common response as the result. To implement self-consistency prompting, we can define multiple prompts, or a prompt where the model imagines several independent answers. Here, we ask for several independent experts to solve a mathematical problem determining the number of cars in a parking lot, with the final answer obtained by majority vote. To obtain the final prompt, we combine this instruction with a mathematical problem to solve. In the output, the model gives the response from each expert and aggregates the result to provide a final answer. Since 2 of the 3 experts obtained the number 12, the final answer is 12. Time to practice.
All right. I'm just gonna come back 1 second because I need to figure out some of the stuff here.
Thought prompting is that one thought with flawed reasoning will lead to an unsuccessful outcome. This is where self-consistency
It says one successful thought comes into an unsuccessful outcome.
prompts come in.
So basically it's trying to tell me that when I'm making this guidance of step by step, what is the step that needs to be taken, like as in a sample way, if in my new prompt one of these fails, that means that the final outcome will fail. Okay. And the self-consistency prompt generate multiple chain of thoughts by prompting the model several times.
That generates multiple chain of thought responses by prompting the model several times. The final output is determined by a majority vote, selecting the most common response as the result. To implement self-consistency prompting, we can define multiple prompts, or a prompt where the model imagines several independent answers. Here, we ask for several independent experts to solve a mathematical problem determining the number of cars in a parking lot.
Imagine 3 completely independent experts who reason differently are answering this question. The final answer is obtained by the majority vote. The question is, if there are 10 cars in the parking lot and 3 more cars arrive, half of the number of cars leave. Then half of the current number of cars arrive. How many cars are there in the parking?
With the final answer obtained by majority vote. To obtain the final prompt, we combine this instruction with a mathematical problem to solve.
Okay, so there's like expert 1 opinion, expert 2, and expert 3. So based on the majority vote, the final answer is that there are cars in the parking lot. Okay,
In the output, the model gives the response from each expert and aggregates the result to provide the final answer. Since 2 of the 3 experts obtained the number 12, the final answer is 12. Time to practice.
Okay, I got it. So, reasoning with the chain of thoughts prompt. Chain of thought prompting is helpful to explain the reasoning behind the answer that the model is giving, especially in complex tasks generating a solution for a mathematical problem or riddle. In this exercise, you will craft a chain of thought prompt to let the language model guess the age of your friend father based on some information you will provide. So this is defined as before, and this create a chain of thought prompt to determine your friend's father age. In 10 years, given that he is currently twice your friend's. Given that he is currently twice your friend's age and your friend is 20. Okay, so what I would do is like I'll get you're going to determine the age of your friends are in 10 years. For that, you know that your friend's father is twice your friend's age and your friend is currently 20. So then that will mean that his father is 40. If his father is 40, that means that in 10 years he will be 50. So here I'm putting the chain of thought. Current age is 40, in 10 years he will be 50 years old. But if I submit the answer, I don't know if that's correct. Create a chain of thought. So I guess I'll need to indicate here. So I guess show the process of calculation step by step. Okay. So in this, wait 1 second. This is gonna be interesting because, and now I'm gonna run it locally. This is gonna be called chain of thought. If that's the correct thought, yeah, that's the correct one. So I'm gonna do this here, and then I'm going to run Python 14. Then in this result, I need to get the step-by-step answer how this calculation was being done. So here you see identify your friend's current age. Your friend's currently 20 years old. Calculate your friend's father current age. According to the information, your friend father is twice your friend. So calculate text for 4 years old. Calculate your so he detected he's 40. His friend's father is 40. Your friend is in 10 years to find this is his current age. So 40 plus 10 is 50. Your friend's father is 50 years old in 10 years old. I guess that if I don't put this step by step, I will not have this whole explanation. So that's basically the whole chain of thought. Oh, that's good. Let's continue with the next one. One-shot chain of thought prompts. When you need to sum the even numbers within a given set, you first. Okay, I'm gonna take this. This is hard. When you need to sum the even numbers within a given set, you first have to identify these even numbers and then sum them. You can teach this to a language model via one or more examples, and it will follow this strategy to operate new sets. Your goal in this exercise is to teach the model how to apply this procedure on the following set, and then ask the model to perform it on a new set. This is how you perform a chain of thought prompting through one-shot prompting. So here I'm gonna put the example. Send the even numbers in the following set, and here I should put this set. Define a question. Even the answer. The even numbers are 10, 4 and 2. I'm also gonna put this in set. 9 and 13 are odd. Adding them is 10 plus 4 plus 2, which will be 16. And here in the answer I define how should be the chain of thought of this question. So then I'm gonna ask the same question here in this part, but I'm gonna do this here. I'm gonna put the new set, and then the prompt should be example plus the question. Some of the even numbers in the set 15, 13, 82 is 96. So it will be 82 plus 14 is 96. Good. Then it will be one-shot chain of thought. One-shot chain of thought. And then I'm here. I'm gonna copy this here. And then I'm gonna run it Python 15. Yeah, it's showing me the logic here. 82 and 14, and then it's 42 plus 14 is 96. It's good. Self-consistency prompts. Imagine you own a store that sells laptops and mobile phones. You start your day with 50 devices in the store, out of which 60% are mobile phones. Through the day, throughout the day, 3 clients visited the store. Each of them bought one mobile phone, and one of them bought additionally a laptop. Also, you added to your collection 10 laptops and 5 mobile phones. How many laptops and mobile phones do you have by the end of the day? Problem is defined in the problem to solve string. You will use a self-consistency prompt to solve it. So these packages are loaded already as before. Plus the max tokens to help the exercise run faster. Okay. create the self-consistency instruction. So I assume that here I need to do problem to solve plus self-consistency instruction. And here I'm gonna have, like, let's say so I'm gonna define here something like expert 1, expert 2, expert 3. I'm gonna take a hint because okay, in the first one is 50 devices and 60% are mobile phones. That means that over 10 times 6, that over 10 is 5 times 6 is 30. 30 are mobile phones and 20 are laptops. And then it says for the day 3 clients visited the store, each of them bought a mobile phone and one of them bought additionally a laptop. So during the day it was bought 3 phones and 1 laptop, meaning there is 27 phones left and 19 laptops left. How many laptops and mobile phones do you have by the end of the day? So this is one example. So here you have the 50 devices in the store. Also says here, also you added to your collection 10 laptops and 5 more. After the owner added 10 laptops, 5 mobile phones. Which means that finally we will have 27 plus 5, which will plus 5, which will be 32 phones, and 10 laptops. It was 1929 laptops. In total we will have, it will be 61 devices. Okay, so this is one expert. Okay, let's see the answer because I don't know what the solution. So I don't need to define what is the expert of each. What is the each one of the logics. I will ask the AI to think in 3 different ways, and then the final answer is obtained by majority vote. Okay, so this is interesting. So in that case, this prompt is completely wrong. And what I will need to do is say like this, like imagine three experts applying different calculations to find the final number of devices. And then it says the final answer is obtained majority vote. And then the question is, okay, this is new. Yeah, so basically what we're doing here is asking the AI to think in like three. It can be even more. You can just, and then by majority vote we define what is the correct answer. So let's just run this to see what we get. Okay, here I got limited the number of the number of I think it was cut here by the number of tokens. So what I'm gonna do here is I'm gonna call it self consistency, and here I'm not gonna define the maximum number of tokens. So in this way I can see like the three logics that were applied. Let's see, we're gonna go here. Yeah, and then I'm gonna run the Python, which is will be 16. So as you might see here, so the expert, so here I will see like three experts. Each one expert has a different count. In this case, the majority is like expert A and C find out that there was 61 devices. So therefore the final answer is like 61 devices. This couldn't be found out here because here you have the maximum number of tokens. But if you run it in your local machine, you will see that you can see the three answers of the three experts, and because of the majority of them show that it's 61 devices, then the final answer is 61 devices. Let's submit this. Good. Okay, iterative prompt engineering and refinement. Let's see, what is this?
Let's explore iterative prompt engineering and refinement, a paradigm that can be applied to any type of prompt we previously covered. Even with the many techniques we have learned, prompt engineering doesn't always succeed on the first try. It is an iterative process where we build a prompt, feed it to the model, observe and analyze the output, and accordingly reiterate to make the prompt better. Sometimes we must refine our prompt because the model misunderstands the request. For example, asking it to generate an Excel sheet with 5 students' names and grades might prompt it to create an actual Excel file, which it can't do. Refining the prompt to ask for a table that we can copy into Excel gives us a better output. Prompt refinement can also help tailor responses to our requirements. Let's illustrate this by analyzing a Python function that calculates the area of a rectangle given its length and width. We start with a prompt asking the model to analyze the code in one sentence. The output correctly states the code calculates a rectangle's area given its length and width. However, we wanted more details, like the programming language used. In this case, we need to iteratively refine the prompt. We modify the initial prompt to ask explicitly for the programming language, and accordingly the model mentions that the function is written in Python. Now, suppose we want to get structured information about the function, like a short description, the programming language, the inputs, and the outputs. We explicitly mention this in the prompt and feed it to the model. The output incorporates all the elements we requested in our refined prompt. Iterative prompt engineering isn't limited to standard prompts. For example, to classify weather descriptions using a few-shot prompt, we provide sample weather descriptions with classifications and a new description for the model to classify. As we can see, the model accurately classifies it as snowy, even without prior examples of snowy. But what happens if we want to classify a description stating the wind of change brought a refreshing breeze to the company's operations? The model mistakenly classifies it as windy, despite not being related to weather at all. To refine the few-shot prompt, we refine its examples. In this case, we add one example stating the political climate in the country was stormy and assign it to the class unknown. The model correctly classifies the previous description as unknown. It's been provided with enough information to classify such cases. Prompt refinement applies to all prompt types. We refine examples in few-shot prompts, guiding steps in multi-step prompts, and problem descriptions in chain of thought and self-consistency prompts. The model may generate incorrect responses due to a lack of domain knowledge, which we will address in later chapters.
Okay, so basically it's saying that in any way of the techniques that you choose, for example, here's like the self-consistency, you have the one shot, in any of these, you can always refine it. You can always like add more examples. If there is few shots, if there is like 2 examples, you can get 3 examples. If the, for example, in the self-consistency, if there's like 3 experts, you can have 4, 5, 6 experts. You can just modify the prompt, so it's like, so you finally reach the result that you want to achieve. I got it. Okay, so iterative prompt engineering process. No prompt can be perfect at the beginning, which is why prompt engineering is considered an iterative process in which you keep updating and refining your prompts to get the desired output. Okay. So first, I guess it's like craft a prompt, observe and analyze the output, identify potential issues with the prompt, refine the prompt, send the prompt to the model. Okay, so first craft the prompt, send the prompt to the model. But this is also sending the prompt to the model. It could be like, okay, I think it's too exact. Craft the prompt, send the prompt to the model. Then identify, observe and analyze the output. Identify potential with the prompt, refine the prompt. Okay, now it's good. Okay, iterative prompt engineering for standard prompts. You're a developer using prompt engineering techniques for your various tasks, and you want to carefully select the right language model. You write an initial prompt to know whether the top 10 pre-trained language models out there. Now your goal is to refine this prompt to generate a table presenting information of each model, their release year, and its owning company. Refine a prompt to get a table with 3 columns for the top 10 pre-trained language models, listing the model name, release year, and owning company. Okay, so just to explain you, what I'm gonna do now is like try to refine this prompt so I get like exactly the information that I want, but you know, step by step. Like for example, here I'm gonna run the code, and it will just probably show me 10 pre-trained language models. Yeah, it's just giving information about it. And I'm gonna refine it like you are an expert in AI. And then let's say define the top 10 pre-trained language models. After, generate a table with 3 columns. So far now I will generate the table with 3 columns, but as far as I didn't define the name, release year, and owning company, it will just probably name, description. But if you see, like, there is not the year here, and I want to have the model, release year, and owning company. So I will define now the column names are name, release year, and owning company. So now I should get all of these fields that I want. Release year, owning company. Nice. So this is more or less what I wanted. So I guess just to save this as a way of documentation, I'm gonna put the iterative prompt hearing. And here I'm gonna put this. And here I'm gonna put trial 1. Here I'm gonna put trial 2. So here's the first one. Here's the second one. The third one is already with the column names and everything. A table with 3 columns. Nice. I don't need to run this. I think it's super simple. I'm gonna submit the answer. Here is the next one. Iterative prompt engineering for few-shot prompts. You're currently working on a project at your current content creation company. The project objective is to develop a text classification model capable of accurately identifying and categorizing different emotions in text. It says happiness, sadness, and fear. In cases where the text does not contain any desirable emotion, you aim to the model to respond with no explicit emotion. Okay, so categorization, emotion. If there is no emotion, just say no explicit emotion. You say to the broader future prompt. However, you notice that time flies like an arrow is being incorrectly classified as a surprise. The use is now to define a prompt so that the model classifies this particular example as no explicit emotion. Okay, so now if I run this, here I will assign an emotion containment, which is not correct. I'm just gonna put it at few shot, and this is gonna be number 10. And here in the first one, I'll do this, which is the trial 1. And this I'm gonna all comment it because in the trial 2, what I'm gonna do is receiving a promotion at work made me feel the note of happiness. The movie's ending, then with a high feeling of my chest sadness. The walking alone in the dark alley sends shivers down my spine. Fear. Okay, another one. All together started listening to the music. And to this, for example, I will explicitly say that this is no explicit emotion because there is no any emotions shown here. And then another one, even with just this, it should already show the no explicit emotion. Maybe they all lay in the sofa. This should also be no explicit emotion. If I run this code, yeah, that's correct. So this is the answer we wanted to reach to. Good. Yeah, I think it's good to start. I mean, it's not that advanced, super advanced engineering, but I think it's good. Uh, Now we have been streaming for 35 minutes. So I'm gonna take a small break and then we're gonna continue with the second part of this, which is text summarization. I'm gonna check what is left from here. So now I have prompt engineering for business applications and prompt engineering for chat development. Yeah. After this I think we have a project. So maybe tomorrow we'll focus on doing this project too. Yeah, planning trip to with OpenAI API. And then probably on Thursday we'll start working with Hugging Face. So yeah, let's take a break and let's come back with the second part of the prompt engineering with OpenAI API.